These water harvesting structures are found in the East UP and Bihar as shown. East UP and Bihar. This system based on slope is similar to Khadin. The bunds are constructed within the 1:2 ratio of upstream and downstream slope. The earthen buns are about 3 meter high. Runoff water is collected behind the bund. A spillways is provided to release surplus water and avoid damage to earthen bund. Concrete or cast iron pipes with diameter of 15 to 30 centimeter are fitted in bunds at an interval of the 60 to 80 meter distance for irrigation purposes. Gates are also provided to drain out water from the bunds if sufficient quantity for pre-showing irrigation. Next we have Johad. There are small earthen check dams used to capture conserve rainwater and improve groundwater recharges. In recent times, a large number of johads has been revived, resulting in rise in groundwater levels and increase in the forest coverage in Rajasthan. This has resulted in dry rivers flowing with water. We have the Saza Kuwa. An open well with multiple owners is the most important source of irrigation in the Ravli Hills in Mewar in eastern Rajasthan. The soil dug out during well construction is used to construct a huge circular foundation or an elevated platform sloping away from the well. Elevated platform is used for rihat and sloping platform is used for chara drawn by buffaloes. Next is the rahat. The Persian wheel consists of a chain and a row of buckets mounted on an open spoke drum and provided with a suitable driving mechanic during its operation. The bucket drum revolves, causing the buckets at the lower end of the chain to get filled with water and carried to the top with their open mouth upward. The buckets get filled by into the water in the well. Next, we have the kund or kundi. It has a saucer-shaped catchment area that gently slopes toward the center where the well is situated. It looks like an upturned cup nestling in a saucer as shown. These structure harvest rainwater for drinking in the Thar Desert in Rajasthan and Gujarat. A wire mesh across water inlets prevent debris from falling into the well pit. The sides of the well pit are covered with the disinfectant lime and ash. Most pits have a dome-shaped cover or at least a lid to protect the water. The depth and the diameter of kunds depend on their. Next, we have the kuis or barriers. These are 10 to 12-meter deep pits dug near town to collect the seepage in Rajasthan and can also be used to harvest rainwater in areas with mega rainfall. The mouth of the pit is usually very narrow so as to prevent the collected water from evaporating. The pit gets wider as it burrows under the ground so that the water can seep in into a large surface area. The openings of these entirely kucha earthen structures are generally covered with the planks of wood. It is kacha. Next we have the bowries or birds. Bowries or birds. These are community wells in Rajasthan used mainly for drinking. Most of them are very old and hold water for a long time because of almost negligible water evaporation. Then we have the Jahalras. They are rectangular tanks in Rajasthan and Gujarat are used for community and religious purposes. Jahalars are groundwater bodies to ensure easy and regular supply of water to the surrounding areas. They collect seepage of a talab or a lake located upstream. Its water is used only for community bathing and religious rites. Next, we have the kare or kere. Tanks collected kere in Kannada were used for predominant traditional method of irrigation in central Karnataka plateau. In this technique, the tanks built in series few kilometers apart are fed either by the channels branching off from the Anicuts, which is the chest dams built across streams or by streams in valleys. The outflow from one tank supplies water to the next and so on. This ensured no wastage through overflow, and the seepage of a tank higher up in the series is collected in the next tank in the downstream. Then we have the power system also. Of rainwater harvesting known as Patali Pani is the most predominant form of rainwater harvesting in Rajasthan. In this technique, rainwater flows from the agar catchment and the percolates into the sandy soil. Kuis or barriers, which is 5 to 12-meter deep, are dug in the agar, which is a storage area, to facilitate percolation. This structure is constructed using masonry technology. Then we have the Irai, which is the Irai. It is the approximately one third of the irrigated area of the Tamil Nadu in water by Aris tanks. Have played several important roles in maintaining ecological harmony as flood control systems, preventing soil erosion and wastage of runoff during periods of heavy rainfall, and recharging the groundwater in the surrounding areas. The presence of areas provided an appropriate microclimate for the local areas. Without areas, paddy cultivation would have been impossible. Next, we have the Kuls. Kuls are water channels in mountain regions carrying water from glaciers to villages in the Spiti Valley of Himachal Pradesh and Jammu's in muddy terrain. It is lined with the rocks to avoid clogging. Then we have the runoff water storage structure. Runoff water storage structures. Once rainfall in the form of surface runoff has been harvested, it needs to be collected and stored properly in different water storage structures in order to use the valuable resource efficiently. Stored water can either be used for multiple purposes such as life saving irrigation, domestic and livestock use, and fishery, or can be directed to recharging groundwater. Water can be stored either in dugout, ponds, storage tanks, and diversion bunds or channels. Water harvesting pond storage tank. Pond storage tanks should be constructed at lower or middle reaches of the hill slope in order to receive runoff from the catchment during monsoon season. The size of the pond depends upon the amount of annual rainfall and area of catchment. Generally, dugout cum embankment ponds are constructed in hilly areas for collection of runoff. The size of the pond is decided mainly on the basis of the water requirement and the catchment area. The storage capacity should at least be two times the total water requirement to take care of evaporation and seepage losses. 10% extra storage may be provided for sediment deposition. Embankment type of ponds are created by constructing a small length of dam across the water course, whereas dugout cum embankment type of pond can be created by excavating a site surrounded by hillocks from two or three sides and making the embankment from excavated soil on the remaining sides. Depending upon the site conditions, storage earthwork ratio of 5 to 20 can be achieved for embankment and dugout cum embankment. In flat areas, dugout ponds are constructed with the storage or the earthwork ratio of the around 1:1. Next, we have the diversion bund or channel. Runoff water runoff from a catchment ultimately flows out of the catchment through a network of drains. This water can be harvested by diverting it into a storage structure or to a field to increase soil moisture. In the same way, seasonal and the perennial streams are also diverted for beneficial use. Diversion of stream can only be achieved by constructing a bund and or channel in the catchment. Even overland flow can be diverted to a desired location by constructing bund made of soil, stone, or cement concrete. Then we have the water spreading. The flowing water is spread over a large area in order to recharge groundwater. Water spreading can also be achieved by diverting the flow water to an earthen pond natural depression which serves as a percolation tank. Construction of Nala Bund or check dam at appropriate location also creates water spreading. Rooftop rainwater harvesting. Water is essential for life and its proper use is crucial for its long term sustainability. The rapid pace of growth of population and consequent urbanization has put considerable stress on available water resources due to overuse of surface supplies and overexploitation of groundwater. Water scarcity is posing serious problems for human existence in the entire world in general and the South Asian countries in particular. In India, availability of fresh water is highly limited and too inadequate to meet water requirement of different users. In large parts of the country, fresh water is being overexploited, which means the groundwater withdrawal far exceeds the recharge from the different sources. As a result of this, groundwater levels have declined to such an extent in several parts of the country that further groundwater development is no longer feasible. Rooftop rainwater harvesting is 1.24 is an ideal and the efficient practice for recharging depleting aquifers in urban areas and providing water for different purposes including drinking. This practice is being used extensively in major urban areas of the country. Several state governments have taken measures to make this practice mandatory. Different aspects of rooftop rainwater harvesting have been treated in sufficient detail. Water harvesting for crop production. Water harvesting and storage in surface pond depressions ensure the availability of water during water scarcity periods for domestic and the livestock consumption and crop production. A part of stored water is used for recharging groundwater also, which can be used subsequently for supplemental in low rainfall areas. In situ, stored water can be efficiently used for providing life-saving irrigation to crops under rain-fed conditions. Rainwater harvesting thus plays a vital and a significant role in increasing food production under such conditions. The various aspects of consumption of harvested water for crop production have been adequately discussed. Okay, so water harvesting is the collection, storage, and conservation of rainwater for its productive use in irrigation, domestic, and industry sectors. In situ soil and water conservation techniques such as counter bending, bench terracing, counter trenching, nala bending, and counter vegetative barriers provide adequate soil moisture during critical periods of crop growth. Water harvesting using traditional indigenous knowledge and the skill of the local people has been in practice since time immemorial. Depending on the variable agrohydrological conditions in the country, different water harvesting structures have been developed and used. The rapid rate of growth of population and consequent urbanization has put considerable stress on available water resources due to overuse of surface supplies and overexploitation of groundwater. Rooftop rainwater harvesting is an ideal and efficient practice for recharging depleting groundwaters, providing life-saving irrigation and drinking water. Harvested water can be efficiently used for providing supplemental irrigation to crops under rain-fed conditions. The conserved soil moisture helps in raising crop productivity in rain-fed conditions immensely. Bench terrace. It is a level or nearly level platform constructed along the contours by half cutting and half filling on the hill slopes. Catchment. It is defined as area which drains water to a single point. The area is called catchment of that point. Contour. It is a line joining the points of equal elevation above the mean sea level. Counterbund. It is a small embankment constructed along the contours of the land at certain intervals depending upon slope and amount of rainfall. Contour hedgerow. It is a line of closely spaced shrubs and tree species planted and trained to form a barrier on the contours. Contour trench. It is open drain of small cross section constructed along the contours on the slopy field. Groundwater recharge. It is a hydrological process of addition of surface water by way of its movement below the ground and meeting the groundwater resulting in increase in groundwater table. In situ water harvesting, it may be defined as harvesting rainwater where it falls in the soil profile. Runoff is that portion of rainfall reaching the land surface which flows over the surface as overland flow after fulfilling the other needs such as infiltration into the soil, depression, storage surface, and the channel detention. Water harvesting may be defined as collection, storage, and conservation of any form of water, rainwater, runoff, stream flow for its productive use for irrigation, domestic and livestock consumption, and fish rearing.